and in this video we're going to look at binary numbers. So if you already understand binary numbers or you're just immensely bored by the topic, feel free to skip this video, but I wanted to insert it here because it strikes me that before I talk about types, or maybe after I talk about C++ types, we probably should look a bit at numbers and computer memory for that matter. So in kind of what we call decimal numbers, the normal number system, we could write a number like this, 372, let's say. And what that actually means, you might remember from primary school, is it means 2 times 1. So this bit is 2 times 1. This bit is 7 times 10. So 7 times 10. And this bit is 3 times 100. So this is the decimal system based on tens. And the rightmost number here tells you how many ones you've got, then it's how many tens, then how many lots of 10 times 10, then how many lots of 10 times 10 times 10, then how many lots of 10 to the power of 5, and so on. And the binary number system is really simple, it's really similar. We just use noughts and ones. There are only 2 numbers in it. And the way it works is, let's take a number like this, 1, 0, 1, 1. What does that mean? Well, here we've got 1 times 1, just as in the decimal system. But here, we've got, instead of 1 times 10, we've got 1 times 2, so 1 times 2. And here we've got 0 times 2 times 2, in other words, 0 times 4. And here we've got 1 times 2 times 2 times 2, in other words, 1 times 8. So altogether the number is going to be, in decimal, it's going to be 8 plus 4, no, not 4 because we've got no 4s, 8 plus 2 plus 1, which is 11. So this is 11 in binary. Let me just check that. We've got 1 plus 2, that's 3, plus there's no 4s, and we've got 8, so that's 11. Now, the reason this is important is because the computer's memory is organized in like a series of cells. You can think of it as like a series of cells like this, and each cell is called a bit. So let's label one of these a bit. So we've got 4 bits here. And to represent this number 1011, which is 11 in decimal, we could switch each bit on or off. So each bit has 2 possible states, which we could call on or off, or we could represent it with 0 or 1. It doesn't matter really what we call it. 2 possible states. So we can make this on, or whatever you like to call it. We could say this is off, this is on, this is on, and then we've represented the number 1011 in binary, which is 11. Hopefully I haven't lost you so far. If I have, don't worry too much, because you rarely have to think about this as a programmer. That's really, as in seldom. My Derbyshire accent really and rarely are quite similar for me. But yeah, you don't very often have to think about this, but I just thought I'd better run it past you for the sake of completeness. So that's binary numbers for you. And the other thing I want to mention is that bits in the computer's memory are organized into bytes. So a bit is 8 bytes. So let's have 1, 2, 3, 4, 5, 6, 7, 8. So we've got 8 cells here. Let's check this. 1, 2, 3, 4, 5, 6, 7, 8. And this is called 1 byte. So we've got bits and bytes, and there's going to be like a limit to what size number you can represent in a byte, and we're going to get onto that probably in the next video after the next one, like in the next video but one, because the thing that you need to know, really the practical thing here most of the time, is just that you need to be aware that there are minimum and maximum values that you can fit into a certain amount of memory. You also sometimes need to allocate memory to put stuff in it, and then you need to be aware that memory comes in bytes and bits. So that's all I'm going to cover for this tutorial. Very quick introduction to binary numbers here. In the next tutorial, I think we will get on to looking at C++ types.